This is the last video of new material for the data structures class. And in this chapter, in the sections video, we're going to talk about the standard template library. So the standard template library was added to C++ in 1994. It came out of a movement toward more what's known as generic programming. Generic programming means that you can have a function, you can have an algorithm that will take multiple data types. And we've done this with the templated function we've done a bunch of those using the template keyword with the class type. Type can be whatever variable name you want, but it's a variable for the type, whether it's an int, double, string, or it could be something you've created as an instance of a class. Okay, we've seen it with node types, for example, a lot. Okay, so again, the standard template library is a way to have these generic classes and generic functions. So they take all the different types, and they're able to handle common data structures that we're going to need and algorithms on those data structures. Okay, so this template library, so the STL, is going to do a lot of what we've covered in this class. So a natural question may be, why did we have to create them all by hand? Well, the answer to that is a couple of things. The first one is that by coding the data structures yourself, okay, that you get a much greater understanding of the inner workings of those data structures. It gives you more insight into how and when to use them. And if something's got to be done differently, you'll understand it, okay? It also simply gives us a chance to expand our programming knowledge and our programming skills. The programs that we've done this semester are pretty intense. They're pretty highly technical, and it's good practice for us. And then I think that the final reason is potentially the biggest reason is in that there will be times in your programming career, whether it's on your senior project here at school, or whether it's on the job, or wherever it's at, there are going to be times when, due to memory constraints or other custom conditions, that you'll need to create custom data structures. You'll need to be able to do it yourself. So it really is a skill that it's assumed any programmer has. Okay, so I'm going to go through the first kind of the overall grand picture of what it has to offer, and then we'll focus on some information from the book about the vector class in particular, and then we'll do some programs of various types of structures. Okay, so the big breakdowns of standard template library, it starts with the containers. Okay, that's number one, and then some algorithms, and then finally some iterators. I'm sorry, there's four, and functions and function objects. Okay, so the containers then are just going to be data structures that store collections of objects of some sort. Okay, the objects could be an integer, it could be a custom data type that you've created. So the containers are divided into three basic groups. Okay, those three basic groups allow for different types of things you need to do with them, different data you can hold, and some are more efficient than others for certain tasks. Okay, and those get broken down into the sequence containers, the associative containers, and then the unordered containers, which are kind of a version of the associative containers. Okay, so the sequence containers, sequence there is important. The keyword, they maintain the order of the elements. So all of these, there is a list. There's an order to them, and you can iterate, and it's going to be in the same order every time. Okay, and probably the most common and what will be the most familiar to us is the vector. The vector is a dynamic array. It functions very much like an array, has the same pros, same cons, in that you can put things anywhere. You get direct access to the whole thing. So just like what you would expect. The DQ is a double-ended queue. You can add to the front, add to the back. There's a list, which is a doubly linked list, so it's built in. You can go forward and backwards through it. There's an array, fixed size array. A forward list is a singly linked list, so there's a linked list as well. What you don't see here is a tree. Okay, so there's not a tree per se, but you can create it from other parts. Okay, so as opposed to those with the maintained order of elements, you have the associative containers, which are like the associative arrays. We did these in Python, where we're going to have key value pairs in some way. Okay, so the dictionary is what we did mostly in Python. Okay, so the first of these is the set. A set is it models a mathematical set. So every element of a set is unique. Sets are restricted to a certain data type. There's a map. The map is the direct representative of the dictionaries in Python, and that allows for a collection of key value pairs. Again, the keys have to be unique. Okay. There's a multi-set, which is like a set, but allows for them to be duplicates. And there's a multi-map, which is like a map, except it allows for there to be duplicate keys. Okay. We then have some unordered containers. So these are containers they're associative containers, but they've been made in such a way to allow near, hopefully, average constant time complexity for the search, insert, and delete operations. So they're built in a different way for that. So there's an unordered set, unordered map, and then an unordered multi-set and multi-map. Okay. There's some algorithms that are included in the STL that function on the containers. So there's a wide range of these. So here are some of the examples. There are more. There's good documentation online for the STL. There are books you can get, websites, the whole thing. You can type it into Google to ask. You can ask ChatGPT to give you examples, all of that. Okay. Here are some of the things you can do. You can do a sort, you can do a find, you can do a copy. There's a for each, which functions kind of like the for does in Python. And it's going to apply a function to some range of elements. Okay. There's a transform, which applies a function to each element in the range and then stores that result in another range or another data structure. Okay. The STL also includes iterators. So iterators are objects that point to elements within the container, and they're used to traverse the data structure, okay, to go through the elements of the container. Okay, so these iterators have a uniform interface for accessing the elements, no matter what the type. So the main types of iterators we have are the input iterators, which allow us to read from the container. Output iterators write to the container. Forward iterators will traverse the container just in one direction. The bidirectional iterators go in both directions. And then the random access iterators will go to any element directly in the container. Okay. There are also some functions or function objects that can be used as though they are a function. They're created by overloading the operator function. Okay. And they're used a lot in the STL for greater flexibility. We won't cover them anymore, but just know that they're out there. Okay. So the one example that we're going to cover in a little more detail is going to be the vector. Okay. So again, the vector is going to allow us to basically work like an array, but it's a dynamic array. The dynamic here, if you remember, means that the memory is not allocated until runtime. So you can decide in the program based on variables what the reserve space of the vector is going to be. Okay. So you can insert wherever you want, but inserting in the middle or the beginning of the array is time consuming, because even though it acts like an array, it is stored internally more like a linked list. Okay, so you can insert it in the array without any additional code, but you take a performance hit. And so the easiest way to insert things is toward the end, which is really fast. Okay, that's what it expects. Okay, so if we're going to use this, the class there that implements this is vector. If you're not using namespace standard, you have to put the std : in front of it. But if not, if we include vector, we'll have the ability to access the vector. Okay. So if we want to define an object of type vector, then we have to, it's a templated thing. So we have to put in the kind of thing that it is. Okay. So if we were to say this statement here, this vector int list, it's a vector of integers. If we would say vector string list, then string list would be a vector of strings. Okay. And again, vectors have to maintain the same type. They have to all be the same type. Okay. So here's some ways that we can declare and initiate our vector. Again, the element type is going to be the type that it is. This is the basic one. Okay. This just creates the empty vector, and this uses the default constructor. Again, we've coded all of these parts before, so we can understand what they do. This version of creating a new one is going to use the copy constructor. Okay. That is part of the vector library, okay? Here's another one here where we're going to create a vector of a certain size, okay? And then some other ways that we can do this, okay? So these are all from the book. Some other operations here to access the elements of the vector. We can use the vector at some index. It will find whatever position that it's in, okay? Again, this is a sequence container, so they are in order. There will be a fifth element, and if there's that many, and a 45th element or whatever, okay? We can also just do vect list with the brackets to return the element at that index. Those first two work exactly the same. No difference between them, just a syntactical difference. The second one looks more like we would do with an array. Then we have a front, which will return the first element, okay? It does not do a check to see whether it's empty or not. So this could introduce errors unless you check yourself. And the same thing with the back returns the last element, okay? There are various functions we have to determine the size of the vector. We have a capacity, we have an empty, which is like the is empty we've done before. True if it's empty, false if not. We can return the size of the vector, and we can return the maximum size that we could have, okay? So operations we have, once we have a vector, we can clear the vector, which will delete all the elements. We can delete, using the erase, we can delete the elements at a particular position. We can delete a range using the beginning and the end -1, okay? We can do the insert at a position, okay? We can insert a bunch of copies at a certain position, okay? We can do another insert here where we're going to, from beginning to end -1 is inserted into the vec list at the position that's in that position thing, okay, which is to copy that. Sorry, big dog is barking. Let me see if I can pause this for a minute. Sorry about that. That's there was a grave danger. Somebody was walking down the sidewalk. Anyway, he may bark again. If so, I apologize in advance. I'm dog watching at the moment. I usually put him down for a nap, but I haven't yet today. Anyway, besides that, you have different insert items is the item here, basically the idea there, okay? There's a pushback where the element will then be inserted at the end. There's the pop back, which will delete the last element. There's a resize, which allows us to resize the number of elements, okay? And the default constructor will create any new elements that you need. And then we can also change the number of elements here to num, another way to resize, okay? And then the new elements are copies of elements. So I guess this resize, we're saying, you know, resize it to 20 and all the new elements will be equal to 5. You could do that, okay? So there's also a begin and end function for each of the containers. So begin will return the position at the first element, and then the end function returns the position of one past the last element, as we've seen in C++ before, okay? They have no parameters at all. So for example, I could say int vec iterator is equal to the int list.begin, okay? The iterator then points to that first element in int list, and you can go from there. We could do a loop here. There's other ways. Our examples will show different ways to loop, but in this way to loop, we've got here that we're going to go from the int iterator, int vec iterator, which we would have already had to have declared of an iterator type. The int list begin, as long as the int, so we go until the int vec iterator, as long as it's not equal to the end, we keep going. We can do the plus on the iterator, and then we can just output. The star here is because the iterator is a pointer, it's on a location. So by putting the star, we're dereferencing that and get the information that's actually stored at that value. Okay, so that's kind of the idea behind that. Okay. So there are operations that are common to all containers, no matter what we have. Okay, we have a default constructor. We have a constructor that takes parameters. We have the copy constructor, so you can add another object that gets copied in. You can have the destructor. You can have an empty. Again, true if it's empty, false otherwise. You can get the size. Okay, get the max size. You can do a swap, which allows you to swap two items. We have our beginning and end, which return iterators. Okay. The RT begins a reverse end, a reverse beginning, so it starts at the end. The R end is the reverse in, which is at the first element, which you can use in some cases. We can insert, we can erase, we can clear, okay? We also have the assignment operator is already overloaded for us. The equality, double equal sign is working, the not equal works, and all that, okay? And this looks like the same thing again because I copied it twice. So sorry about that. Anyway, so the book does go through more details on all of this as far as different types. It goes through DQs and it goes through sets and lists and all that. And I encourage you to take a look at that. Okay. What I'm going to do instead here is I'm going to go through some examples on the server. I think that's the easiest way. Okay, we're over in the server. I've had to pause again due to a mailman visit, which is, you know, for dogs and a very exciting event. Anyway, so I'm over here on the server and we've got some examples. So let's start with an example of a vector. Okay, so I'm going to look at vector example. Okay, so again, I'm including here the vector library. Okay. I also have to do the using namespace standard, or I would have to put std : in front of all of these. Okay. So here's where I'm declaring a vector called vec as integers, and I'm going ahead and putting in the information, just like we do with a regular array. Okay. I'm then going to use the pushback to add a 6 and a 7 to the end. Okay, so that will add to the end, the right side of the array here. Okay. I'm then going to do an iteration and printing on the vector elements. And this is a different way to do it. This is kind of a shorthand. So we could do it the way we did in the book. But in this case, I'm going to declare an integer variable. Okay. And I'm going to use this colon vector. Okay, which is the name of our vector. And that's going to do like a for each to iterate through this and print out the value each time we go through it. Okay. This looks very Python-like, I think, in some ways. So we'll take a look at this one. Okay, I'm going to compile it. And again, I'm being lazy and not doing a -o. You should not follow my example. Okay, so there we get the 1, 2, 3, 4, 5, 6, 7. Pretty straightforward. Okay. We have another example here where we're going to look at an algorithm with vectors. So in this case, we're including the vector library again. We're also including the algorithm library. Okay. We've created a vector here. In this case, the vector is at random. Okay. So note we have repeats because this is a sequence container, which can have multiple copies of the same thing. So it's not an issue. Okay. We're going to use from the algorithm library the sort. We're sorting from the vec begin. Remember, this function returns a pointer to the first element, all the way to vector end, which is a pointer to the last element. Okay. So this will change vector. So if you want a copy of the unsorted version, you would have to save it using the assignment operator before you did this. Okay. So this is a destructive operation. Okay. We're then going to go through and print it out again the same way we did before. Okay. And then we're going to, so that should be the sorted version of that. We're then going to find an element. So what this is doing, this is using auto. And auto is a relatively new feature in C++. And it just allows us to set the type. It allows C++ to set the type based on what it thinks the type should be. So I could have a variable, for example, I could say auto x is equal to 5. Okay. And it auto would then turn into an int. And there's not always a good reason to do it. I think it's a little sloppy in general. But in this case, we're going to have it be equal to this it here, okay, which is going to go to the find function, and it's going to return a iterator. So rather than having to declare it as an iterator, we just declare it as auto, and it's going to take care of that for us, okay? And then we start, in this case, we can start wherever we want. We're going to start at the beginning, go to the end. We're looking for a 5, okay? And then if the iterator If it's equal to the end, ends one passed, it means it made it all the way in and didn't find anything. Okay, in which case it didn't find it. So if it's equal to vect, if it's equal to vect n, then we go down here and say element's not found. But if it's not equal to vect n, then the item was found, and we can go ahead and print what was at that location. Again, IT is the location. We put the star in front of it to dereference it, and that should say element found 5. Okay, because we did put 5 in our list here. Okay, 5's in 2 locations. This will find the first of those. Okay, run this one. Said I made a change. Hopefully I didn't mess things up. Okay. And there we see there's our sorted vector, and it did correctly deal with the 5s. Okay, it's in now sorted order. It wasn't when we put it in. Okay, and then the element found is 5. Okay, so we want to test that further for items that weren't found, and also print out that really should have printed out the vector before we started. Okay, so here's another example of something we're used to, and this is using the stack example. Okay, so there is a stack library that we can use, and it's going to have the basic functionality we're used to. So I'm creating a stack. This looks very much like the code we've done before. Okay, in fact, some of you use this in your homework, and you should not have, but it's understandable. So when we're pushing elements to the stack, we use the push function to do a 1, 2, 3. Okay, we're then going to print out, this is going to be the stack elements from top to bottom. We're going to say while the stack is not empty, again, we don't know how many elements in our stack. Okay, we're going to print out the top and then do a pop. So all this is perfectly built in. We didn't need to do any of that arduous work to get the basic functionality of a stack. Okay, so now you know if you need it, you pop out this and it works. Okay, so if I run this one, it should be fairly straightforward. Okay, there we go. There's our stack elements from bottom to top. We put in a 1, we pushed a 1, 2, 3. So therefore the 3, 2, 1 comes out on the other side. Okay. Then our final example. No, 2 more examples. We're gonna do an example of let's do a map first. We've seen those before. So a map again is like a dictionary in C++. Okay, hopefully last interruption. Sorry about that. My wife didn't know that I was making a video. So sorry, this has been the noisiest video I think I've ever made. Anyway, so this is an example of using the map. Okay, the map again is pretty much like a dictionary in Python, and then we have key value pairs where the keys are unique. Okay, so again, we're using namespace standard. If not, I'd have to put a standard : in front of each time I use map. So we don't need to do that. So we're creating a map. Here we have our key value pair. Okay, so the key is a string, the value is an int. So we're putting names and ages, basically. Okay, so the age map is the map that we're creating. Okay, this is just like we would do it in Python. Age map for the key Alice, the value is 30. For the key Bob, the value is 25. And for the key Charlie, the value is 35. Okay. Then to get these elements, we can just go to age map on the key, and it should return 30 for Alice's age. The age map for the key Bob should return Bob's age of 25. Okay. We can also iterate through and print all the ages. Okay, so we've got here this auto again. We're gonna get the address of this pair. This is just the way that we do it on maps. We're gonna say the constant auto ampersand pair colon age map. So it's gonna give us in sequence, one at a time, the pairs with a first and a second. Okay, so we're able to see out the pair first, followed by the pair second. Okay, so look at this one. Pilot the lazy way. Okay, and there we have Alice's age is 30, Bob's age is 25. Then all the ages are Alice at 30, Bob at 25, and Charlie at 35. Okay, then our final example, I think, although I've said that before, is on a set. Okay, so again, sets are pretty useful in computer science. They're a mathematical object. The big difference here is you can't have duplicates. They have to be the same type. So again, we're including set. You can include as many of these as you need. We're going to create the set. Again, it's templated or it's typed to an integer called mySet. We're then going to insert the items here. Okay. If we attempt to insert a duplicate, it's not going to let us. We'll see how that works. And then we're going to print out again, similar fashion. We have this int value. It's like the for each with the colon here on mySet. We'll go through one at a time and print out those values. Okay. And that's it. So let's compile this one. Okay, and run it. Okay, and you see that when we try to insert the 3 twice, it doesn't tell us. It just silently doesn't do it. Okay, so you could certainly check if you wanted to warn them, or if it doesn't matter, then that's the default behavior. Okay, so again, the standard template library is very powerful. It has a lot of the things that we did when we were doing our stacks and our queues and all that stuff. So it's certainly worth knowing. It's certainly something if you ever are applying for a job that uses C++, they're going to expect you to know it. And it's worth looking into. If you decide to do your senior project in C++ or any big project, standard template library will be your friend for sure. It cuts down the time a lot. A lot of times people complain about C++ that it doesn't have the plethora of built-in stuff that Java has. And it does, for the most part, through the standard template library. Okay, so it certainly is something to look into. So that's all of the new material. So if you're in my class, what will follow will be a video that will be a review for the final exam. Okay. And as always, if you got questions, make sure you let me know.